Welcome to the fascinating world of space weather. In this exploration, we'll dive deep into how solar activity impacts our planet and the crucial role it plays in modern technology and our daily lives. From breathtaking auroras to disruptions in communication systems, space weather is a powerful force that influences everything from satellite operations to power grids. Today, we'll unravel the complexities of this invisible yet impactful phenomenon and its significance for humanity. Our journey begins with the Sun, a dynamic and ever-changing star at the center of our solar system. The Sun is not just a static ball of gas. It's an intricate and volatile entity, constantly undergoing processes that release immense amounts of energy. Every day, the Sun emits a continuous flow of charged particles known as the solar wind. This stream varies in intensity and composition depending on solar activity. During periods of heightened solar activity, such as solar flares or coronal mass ejections, the solar wind can become particularly intense, sending out significant bursts of energy that can travel millions of miles in mere hours. Solar flares and coronal mass ejections, CMEs, are two of the most powerful and unpredictable events in our solar system. Solar flares are sudden bursts of radiation that can release energy equivalent to billions of atomic bombs within minutes. These flares occur in regions of intense magnetic activity on the Sun's surface. CMEs, on the other hand, are massive clouds of solar plasma and magnetic fields ejected into space, often following a solar flare. When these events occur, they can dramatically alter the conditions of space weather, leading to both stunning natural displays and potential hazards. When a solar flare occurs, it can disrupt communication systems, navigation, and even power grids on Earth. Understanding these events is essential for protecting our technology. Without proper forecasts, we risk significant disruptions in our daily lives, from losing satellite communication to experiencing power outages. For instance, during a significant solar storm in 2012, a CME narrowly missed Earth, but had it been on a direct collision course, the impacts could have been catastrophic. Fortunately, Earth is equipped with a natural defense, its magnetic field. This field acts as a shield, protecting us from the full force of solar radiation. It deflects most charged particles. However, during intense solar events, some can penetrate the magnetic field, particularly at the poles, where the magnetic lines converge, creating what we call the auroral ovals. This interaction not only protects us, but also creates the stunning displays known as the auroras. When a CME reaches Earth, it can trigger geomagnetic storms that cause fluctuations in the magnetic field, with effects that can vary widely. These storms can lead to beautiful auroras in the polar regions, but they can also disrupt technological systems. The induced currents can lead to voltage surges in power lines, causing outages and damage to electrical infrastructure. Historical events, like the 1989 Quebec blackout, remind us of the vulnerabilities in our technological systems and highlight the urgent need for proactive measures to protect against such events. The spectacular northern and southern lights, or auroras, are one of the most beautiful manifestations of space weather. As charged particles collide with gases in our atmosphere, they produce stunning displays of color that dance across the night sky. These displays are not merely visually striking, they also provide valuable insight into the interactions between solar wind and Earth's magnetic field, enhancing our understanding of atmospheric physics. Scientists study these phenomena not only for their beauty, but also for what they reveal about the dynamics of our planet's magnetosphere. Monitoring space weather is crucial for industries like aviation, telecommunications, and even the power sector. We provide forecasts to help them prepare for potential disruptions. Our work allows them to take preventative measures, ensuring the safety and reliability of their services. For example, pilots flying at high altitudes are particularly at risk from increased radiation during solar storms, so timely alerts are vital for their safety. Satellites in orbit are particularly vulnerable to space weather. Increased radiation from solar storms can damage electronics and interfere with their operations, leading to malfunctions that affect everything from GPS navigation to weather forecasting. The health of our satellite infrastructure is essential for modern communication, environmental monitoring, and disaster response. This vulnerability is why space weather forecasts are critical for mission planning and operational safety, allowing engineers to implement shielding or temporarily shut down sensitive equipment during solar storms. Agencies like NASA and NOAA play a pivotal role in monitoring solar activity. Using advanced satellites and ground-based observatories, they gather data on solar phenomena and provide real-time updates on space weather conditions. This information is vital for timely predictions and effective response strategies. Their ability to forecast space weather events helps mitigate potential impacts on critical systems, ensuring that we are prepared for solar storms. Space weather forecasts are generated based on a combination of satellite data, ground-based observations, and sophisticated models of solar activity. These forecasts help us anticipate solar storms, allowing industries and individuals to prepare for potential impacts. For example, energy companies can adjust their operations to safeguard against potential power grid fluctuations, while airlines can reroute flights to avoid high radiation areas. When we're in space, we have to be especially vigilant. Solar radiation can pose health risks, particularly during solar storms. We rely on accurate forecasts to inform our activities and protect our health during missions beyond low Earth orbit. Understanding space weather is crucial for the safety of astronauts and the success of long-duration missions, especially as we aim for Mars and beyond. With future missions planned to the Moon and Mars, our understanding of space weather becomes even more essential. Moreover, space weather isn't just a concern for technology. It also affects our climate and the environment. Changes in solar activity can influence atmospheric conditions, impacting climate patterns on Earth. For example, research suggests that solar cycles may correlate with certain climatic changes, though the exact mechanisms are still under investigation. This intricate relationship underscores the importance of understanding solar dynamics in the broader context of Earth sciences and climate studies. As we advance in our exploration of space, the need for accurate space weather forecasting becomes increasingly vital. Future missions to the Moon, Mars, and beyond will require robust monitoring systems to protect astronauts and equipment from solar radiation and other space weather effects. Innovations in satellite technology and data analytics will enhance our ability to predict and respond to space weather events, safeguarding our ventures into the cosmos. The study of space weather is not just about protecting technology. It's also about deepening our understanding of the Sun-Earth relationship. As we continue to explore space, knowledge of space weather will be essential for future missions, ensuring we can navigate the challenges of the cosmos safely. This knowledge will guide us as we venture farther into the solar system and beyond, highlighting the interconnectedness of our environment and the universe. By understanding space weather, we empower ourselves to safeguard our technology, protect our planet, and inspire future generations to explore the cosmos.